Hello students, today we are going to discuss chapter number 5 surface chemistry, the topic properties of colloidal solutions, protection of lyophobic soles and gold number. Let us start with a very good thought. Destiny is not a matter of chance. So learning outcomes, you would be able to explain about the properties of colloidal solution. Under this category, we have discussed further general physical properties, colligative property, which we have discussed in chapter number 2 of solutions, kinetic mechanical properties, optical properties, Tyndall effect, electrical properties, and the second part involves is protection of lyophobic soles and gold number. Let us start with physical properties. Heterogeneity. Colloidal particles are heterogeneous and they consist of two phases, dispersed and dispersion medium, and it appears to homogeneous. Why? Because the dispersed phase particle size is in nanometer, so it is very difficult to see from our naked eye. So that is the reason that it seems to be homogeneous, but actually it is heterogeneous. Similarly, visibility, as I have discussed already, it is not visible to the naked eye. Third is filterability. Filterability, if you pass through ordinary filter paper, all the dispersed phase and dispersion medium will pass through, but if you are taking the ultrafilter paper or its animal membrane, the dispersed particle will be retained on the ultrafilter paper or cellophane membrane. Next is stability. Earlier also we have discussed about the two types of colloids under the affinity part, that dispersed phase and dispersion medium, lyophilic and lyophobic. So lyophilic, you know that it is more stable as compared to lyophobic. So it depends all upon the how much is the concentration of the electrolyte present in the solution. Similarly, color depends upon the size of the colloidal particles. Larger is the particle size of the colloids or dispersed phase, it absorbs the light of longer wavelength. If it absorbs the light of longer wavelength, so therefore transmitted light would be of shorter wavelength. So depending upon the light absorbed, the transmission of light will be giving the respective color of the solution. Okay, so that if you think of Vibgyor, violet, indigo, blue, green, yellow, red, in that the red is having maximum wavelength. If red is absorbed, so that the solution is likely to be lesser wavelength, that is, it is moving towards the violet side. So this way the complementary color will be obtained. Next is colligative property. So in chapter number 2 of solution of plastic chemistry, we have discussed about the colligative property. Colligative property depends upon the number of solute particles, and the examples for the various colligative properties are relative lowering of vapor pressure, boiling point elevation, freezing point depression, and osmotic pressure. Out of these colligative properties, if you take find the colligative property, the value of that colligative property will be very meager in case of the first three. But if you want to find out the osmotic pressure, that will give you the appropriate value, so that you can derive on any conclusion in regard to colligative property. For example, if you want to calculate the molecular mass of the dispersed phase, so we can calculate by using osmotic pressure. That's why we are saying that is the best colligative property in regard to calculation of molecular weight. And you know that colligative property depends on the number of solute particles or number of colloidal particles and does not depend on the nature. And the osmotic pressure of colloidal solution can be measured with a reasonable degree of accuracy. That's why we are saying that it's best. Next is kinetic or mechanical properties. So in the lower classes also we studied about the Brownian movement. So what is that? Continuous zigzag movement of colloidal particles in the dispersion medium in a colloidal solution is called Brownian movement. What is the reason for that Brownian movement? So it was found by Robert Brown in 1827, and what is the reason is this is unequal bombardment is there. Unequal bombardment of moving molecules of dispersion medium on colloidal particle, means dispersion medium going to strike on the dispersed particle, and there is unequal force operating on that. That's the reason that it will be always in zigzag motion. The colloidal particles are in zigzag motion, and this movement decreases with the increase of size. So you know that the size is increasing, the force of gravity will be becoming more. So that's the reason that suspension do not exhibit this property of rounded movement, and this property is solely responsible for the stability of soul because it acts against the force of gravitation, which is causing the precipitation. Now next is optical properties. Optical properties, if you see the diagram, we have passed the light of beam of light, that is also converged beam of light, and if you are taking true solution, because you know that true solutions are not scattering light because the size is small, so size should be having appreciable size, then only this scattering will take place. Now if you pass this light, converging beam of light through colloidal solution, it will scatter light. And how we can see through microscope, because from eyes we cannot see that. When a converging beam of light is passed through colloidal solution, kept in the dark, but we are putting the light on the solution. So with the angle of 90 degree, we can view the size of the particles, or we can observe the scattering of light by colloidal particles. The path of beam gets illuminated with the bluish light. The phenomenon is called Tyndall effect. Tyndall effect, this easy way also we can write, it is due to scattering of light by the colloidal particles present in a colloidal solution. Please note that this Tyndall effect will not be shown by true solution. Only colloidal solution will show the Tyndall effect. Next, this way. This is the diagram which we are talking of, that the microscope would be at the 90 degree of the light passed, and if you see this view of the microscope would be small dots would be there surrounding with some of the dots will be there, so that is representing the dispersed particles. So when an intense converging light is passed through a colloidal solution, due to scattering, the path of light gets illuminated and appear as cone. So see that the light was passed, so it is appearing as a cone, so that is also known as Tyndall cone. Okay. Now electrical properties. So electrical properties, electric means charge, the presence of charge on a colloidal particles and stability. Now if a particle collides solution, what is happening? The colloidal particle carry the same type of charge, means if I am talking of ferric hydroxide sol, so that will be containing ferric ions over it, or that will be having positive charge sol, while the dispersion medium where it is dissolved, that will be having equal and opposite amount of that negative charge, means positive and negative charge are equally present in the solution. In ferric hydroxide sol, the colloidal ferric hydroxide particles are positively charged, while the dispersion medium carries an equal and opposite negative charge. Means to say that this positive charge will be absorbed on the ferric hydroxide, and overall the ferric hydroxide ions will be having positive charge, and the dispersion will be having opposite negative charge. Now, what do you mean positive and negative? Further example we can take up. So when dispersed phase is a colloidal solution carries a positive charge. Examples are metal hydroxide. Just now we have discussed ferric hydroxide, aluminium hydroxide. Here aluminium AlOH thrice will come, not 2. Methylene blue. So these are the dyes: AlOH thrice, CrOH thrice, titanium dioxide, hemoglobin, basic dyes like methylene blue. Similarly, negative charge sols like silver, copper, along with that platinum, arsenic sulfide, calcium sulfide, starch, acidic dyes. So it means basic dyes are positive in nature and acidic dyes are negative in nature, similar to basic and acid radicals. Now, how charge can be retained? So that was what we were talking of. That is due to preferential adsorption of ions from solution. From the solution, some ions, positive charge ions, will be adsorbed on the ferric hydroxide. That is the example we have taken last time. In this case, AgI, excess, it depends on which solution is excess. If excess of inactive ions are there in the solution, inactive ions are adsorbed on the surface of the AgI, and the overall colloidal particle will become negative charge. However, if excess of silver plus ions are there, then due to preferential adsorption of silver plus, the colloidal particle acquires positive charge. Okay, so it is important to note that total charge, positive charge present on the dispersed phase will be equal and opposite to the dispersion medium. Now, the next electrical property is the electrophoresis. What is that? If you see the diagram, if the U-tube is there, positive and negative terminals are there. Now, the movement of colloidal particles towards a particular electrode under the influence of electric field. Now you can see the U-tube, the positive and negative charge is connected with the battery, and if you are passing the current, if the collider particle carries positive charge, they move towards cathode. It means cathode is negative. Similarly, if anionic particles are there, anode is there, anionic negative charge particle will move towards anode. So this way, and this is the practical application of electroprecipitator, where the dust, coal dust, can be separated from the air by use of electrostatic precipitators. Pollution control, air pollution control, we are using that. Okay. Now you see from here, this collider particles were earlier in the solution, but now it is moving towards the negative charge particle moves towards a positive terminal. Now, electroosmosis, the movement of dispersion medium under the influence of an electric field. In electroosmosis, only dispersion medium is moved and dispersed collider particles are retained with the help of suitable membrane. So the basic function is this only. If you talk of osmosis, electroosmosis, same thing. The medium is moving. Dispersed particles are not going to move because dispersed particles are not able to pass through the membrane which was used in osmosis. Now, the next is coagulation and flocculation. So here the two terms are used one or the other way, but slight difference is there. Wherever the agitation is, flash mixing is there. Wherever flash mixing is there after addition of coagulant, so there it is known as coagulation tank. When there is fast mixing, where this mixing is very slow, then it's called flocculation tank. Okay, so this is the decantation, is the solid particle is settled down and clear we can remove. Flotation is that lighter particle will be float on the surface and heavier particle at the bottom of the liquids. And filtration is the whatever the slurry is there will filter through the filter paper or filter cloth, and the sludge as well as the filtrate is obtained. Okay, the phenomena involving the precipitation of colloidal solution on addition of an electrolyte is called coagulation or flocculation. So when we add the electrolyte, the colloidal solution will be getting precipitated or becoming unstable. So coagulant added and the impurities are removed. So this is basically used in our water treatment plant by the municipal corporations to give you the pure water instead of impure water. Now, one very important rule that is known as Hardy-Schultz rule. It states that coagulating power of an electrolyte increases rapidly with increase in valency. It means more is the valency of cation or anion, more will be the coagulating power. So this is the meaning. For negative charge soul, the coagulating power of electrolytes are AlCl3 greater than BaCl2 greater than NaCl. What is the basic difference you are finding here? Here, more is the charge, more is the power to coagulate. This is the basic difference. And for positive charge soul, the coating power of an electrolyte follow the following order. If positive charge is there, negative charge particles are required. If you talk of FeCN6 negative, this is having maximum charge, so it will be having maximum coagulating power. Similarly, phosphate, PO4 negative and SO4 negative and Cl negative. See, these are the negative charge particles which is going to coagulate the positive charge particles. Next is flocculation value. Minimum concentration in millimoles per liter of an electrolyte required to cause the coagulation of a soul is called flocculation value of the electrolyte. Means how much is the required. If it is required in less quantity, it means the value is less, but power is more. So coagulating power is inversely proportional to coagulation value. Coagulation value is nothing but how much is required. And if it is more efficient, less will be required. So this is the basic difference. More is the coagulating power, lesser is its value. Aluminium is having more coagulating power and lesser coagulation or flocculation value. Now, other methods are like electrophoresis, we have studied earlier, by mixing the opposite. If positive charge soul is there, if you mix with the negative, it will go precipitation. Persistent dialysis, when you do dialysis, the electrolyte is removed. So once the electrolyte is removed, then you are having nothing. So that's why we can say that these methods are also used for method of coagulation apart from the previous method we have discussed. Now stability. What means the stability? How stability can be attained? This is basically we discussed already. That is due to the any type of sol is there that will absorb certain cation or anion depending upon the concentration of the electrolyte. So once lyophobic is unstable. So if lyophobic if you take and if you cover with lyophilic, then lyophilic coating due to coating, so that will remain as stable. So that is the meaning of stability protection of the colloids. So lyophilic colloids are more stable as compared to lyophilic phobic. So lyophobic coating we can do coating of lyophilic over lyophobic. So by giving it more stability. Now protection of lyophobic sols. This only I was discussing in the previous slide also. The process of protecting a lyophobic sol. Lyophobic is weak. That's why we need to save it from being coagulated or precipitated on addition of an electrolyte. So by the use of lyophilic colloids is called protection. So means to say that the colloids can be protected by doing a coating of lyophilic sol, which is more stable as compared to lyophobic sol. And lyophilic colloid is called protection, and the lyophilic colloid used for the purpose is called a protective colloids. And you basically know that lyophobic is water repelling and lyophilic is water loving. So that's why it is more hydrated, more stable. So next is gold number. Gold number of a protective colloid is the minimum amount in milligram, means that amount that I was talking of, milligram, which is just sufficient to prevent the coagulation of 10 milliliter of a gold sol on the addition of 1 milliliter of 10% sodium chloride solution. So what is the meaning? If simply you will take gold sol and if you add sodium chloride solution, it will get precipitated. This is the meaning. So and a full-fledged the system will be spoiled. So now what we have done? We have done the coating of gold, we have done a coating of colloids of lyophilic over lyophobic. So now we are checking that what is the effect of coagulation on addition of sodium chloride. So we are finding that how the minimum amount which is just sufficient to prevent the coagulation of 10 milliliter of gold sol for the addition of 1 ml of 10% sodium chloride solution, means the efforts whatever the required to prevent the coagulation, how much is the quantity of lyophilic sol used to prevent the coagulation, that is called gold number. So gold number is we can say it is a concentration and it is known as coagulation value. So lesser will be the value, more will be the power. Okay. So this is way how we can, this gelatin you see value is very least. So value least means it is highly stable, and value is maximum, so it will be least stable. So now one more term is the zeta potential. So that also we can, this is basically difference. One more question, the definition can be asked is the potential difference existing between the surface of solid particle immersed in a conducting liquid and the bulk of the liquid. When you put the solution in a conducting, when the dispersed phase and dispersion medium are in liquid state and the laxity is passed through or charge is provided on that, so there will be a difference in the potential. There will be difference in the potential in the two layers immersed in a conducting liquid and the bulk liquid. So conducting liquid, bulk liquid, what will be the difference of the potential? That is called zeta potential. So normally they are not asking that. This is just for one question I have seen earlier in one of the assignments, so that's fine. So that's all for today. The properties of colloid we have discussed about the general physical properties where heterogeneity and ultrafilter paper it cannot pass through, that we have discussed. Similarly, Brownian moment we have discussed, and we have discussed about the Tyndall effect and Tyndall cone, and the other electrical properties like osmosis, coagulation and flocculation was discussed in detail. And now next is Hardy-Schule rule. This is very important. Greatest valency of the opposite charge ion. First is the coagulation. Flocculation value and power are inversely proportional. So let us repeat the thought. Destiny is not a matter of chance. So thank you very much to all of you.